Hi folks, and welcome to the channel. In this episode, I've got a really hilarious tutorial for you guys. If you guys remember in the previous episodes, we've kind of covered Petrel's Your Body Interpretation module, which actually extracts reflectors. Like whichever reflector you choose, you can just click on it, you can extract it. This was actually one of the routine procedures for seismic interpretation that is usually done manually, and it is extremely time-consuming and subjective. As you guys know, and the thing about manual seismic interpretation is that by the end of the day, when you're done interpreting your seismic reflectors and other your bodies when you go home, you see seismic reflectors all over the place, like on the walls, on the floor. Seismic reflectors are everywhere, and you can't just get it out of your head. That is the brutal reality of manual interpretation of seismic images. Specifically 3D seismic images, right? But anyways, now having been through that hell that is interpreting seismic images, one of these horrible procedures is the fault interpretation procedure. Let's see how Petrel can handle fault prediction. And from this point on, it really gets worse for Petrel. Naturally, I used to do a lot of seismic interpretations. With the seismic interpretation module, then I kind of came across this new functionality fracture. Her modeling that we have specifically needs fault extraction mortal. So when I first saw this, I was like, hallelujah. We're saved. We don't have to look at these seismic reflectors all day. We can actually just automatically extract these faults. And this is something that you expect. As I said, right? Tries to guess can see glory. Have the patron vacation open and ready to go now. Already gone ahead and loaded this size. Make through the image. Said the reason behind the signs of the image. And why I chose it is that this image has got a clear strike slip fault with a clear direction. As you guys can see, right? And also him shoulder in line. And crossed line sections as well. You can perfectly see the direction of the fault. This shouldn't be too hard for Petrel. If it actually can extract a fault, this should be a very easy task for it, right? Because there's only a single fault in this 3D image. Under the Fracture Modeling tab, we have the Fault Extraction module. Now let me see if I got this straight. It says open the dialog for automatic fault extraction. Alright. Do you guys think this is going to actually salvage our soul and eyes? Or do you think this is just a gimmick? Alright, let's find out. Automatic fault extraction. Let's really do this by the book. So here's this input size. Make edible you from seismology. We know edible limbs are attributes like or variance, right? Now let's take a look at this extra information here. Input and tracking volume. Alright, so evidently it needs in tracking volumes. Drop an end tracking size. Make volume or another edge enhance in size. Make attribute to ask input for the automatic fault patch extraction process. So it either takes A and tracking size, make volume, or another edge enhancing size, make attribute. What do you mean by that? Let me go in the hints tab. Let's find out. We can see that we have the input. So eyes make, and we have this. This means volume attributes. Okay. And this tells us precondition. What do you mean? It says variance and chaos. Alright, so it needs variance and chaos. This looks like an emptiness and tracking volume. And here it says, old patches said okay. So we can get either an Amtrak and get the folk patches from there probably, or we could directly get the fault patches from variance chaos. Now by fault patches, I presume it is the promised extracted fault plane. Probably what it means by the fault patches set, hopefully. So let's do it now. I already have a realized size. Make a match here. Okay, the one that is on display. A variance or chaos. And potentially we also might need the aunt tracking. Image, let's see if we can create an aunt tracking image and what we need for that. And tracking is used to extract faults from a pre-processed seismic volume. The pre-processing could be variance or chaos, combined with structural smoothing. Currently only realized volumes can be calculated, okay. So it's a good thing we already have a realized seismic image. And realizing seismic images is so easy. You just go in the realize modules, nothing. So alright, so for aunt tracking, I think we need a pre-process size and volume. It is chaos or variant with structural smoothing. No problem. So we have to start with chaos, alright? So I'm just going to simply drop the seismic image right here. And then we are going to get our realized version of chaos, right? Alright, what is the next step? It said structural smoothing, right? So let's get the structural smoothing thing. Alright, no problem. Structural smoothing, and voila. We got the structure smoothing now as promised. we should be able to get the hand tracking attribute. Am I right? So there we have the structurally smooth chaos that we had so apply. Let's check. It says chaos structural smoothing and tracking realized. Alright, we're done with that. Let's try it with chaos. Since it says drop in and track seismic volume or another edge enhancing seismic attribute. Right? Okay, no problem. So this time we're going to drop the chaos volume here. Alright. So there we go, chaos and extract fault patches. Let's see how long it takes. Alright, we're done with that. And we got the false patches right. We also have the aunt tracking. I hope you guys are ready for the big reveal. Let's go ahead and see it. Alright, so... Alright. This is just crazy. This is ridiculous, guys. What the hell is this? I mean, we know that it's working because kind of the default is there. You might see it. But what? There's all this junk all over the place. This looks like a preschool confetti project, really. We're not getting our money's worth out of this. But anyway, so let's just give it the hand tracking. By the way, let's kind of look at it. Actually really curious to see what it looks like. So apparently this is what it looks like. And we did exactly everything by the book, right? We created Chaos Truck, really smoothed it. Then we did the end tracking. Alright, so here's the end tracking version. Extract full patches. Let's see how ridiculous this one is. Alright, this is another level of ridiculous. I mean, honestly, the normal version was better. At least we were getting something out of this. But guys, this is not what you might expect from a $60 billion company. $100,000 application. But anyways, so guys, when I say commercial applications are actually struggling to keep up with the state of the art, that's exactly what I mean. Because this is clearly not using neural networks, right? And you guys saw how many hoops we had to jump through, right? Creating one attribute after the other. Like first we had to deal with chaos and then structurally smooth it. And then in tracking, we were promised to get a fault plane. And we ended up with this miserable excuse for a fault blame. Now let's see what our community-driven platform has to offer. Okay, since in seismic flow, we can easily use pre-trained neural networks directly. We can load neural networks pre-trained neural networks into the platform. The state-of-the-art neural networks nowadays, people are working with 3D combination on the world that works, and their combination with attention. My cancers, that's a new thing, this is a 2024, 2025 kind of a deal, and it is the current state of the art. Okay, not like this confetti project we got going on over here. Alright, so as you guys can then see, we already have the platform size and flow ready to go. So we have the same 3D seismic image. And let me show you the fault. I think here I can show you better. Or just where the fault plane actually cuts through this 3D image. As you guys can see, so this is clearly the direction of the fault plane, right? Okay, and then take a look at here. The fault plane right here. Then we have it just about here. Right, guys? And the coolest thing is that take a look moves. Do you see it moving? Right here. They kind of join. See, this is where it is, and taking a look here, you can see it. Right, so that's where we have our full plane. With pack. Start, you see? Right here. Right here, and we have it here, right? So, this is the data we're dealing with, the same exact image. Alright. So what I'm gonna do here, okay, is I'm gonna go to the tools module of our very own community-driven platform size flow. Right here we have the gel body segmentation module. And the thing about making this application community-driven was that you can actually use open source neural network models that were literally trained yesterday, right? Somebody, for example, published their neural network model on GitHub or Kaggle. Simply download them. Load it into the application and have it find the faults, right? So it's very simple. So do a body segmentation. Here we go. I just have this ready convolutional neural network model here. It's actually let's see how it works. All we do is just to load it, give it the batch size. I think a batch size of 6 is good depending on your GPU. So the thing about seismic flow is that it uses GPU acceleration. It's got native GPU support for TensorFlow and PyTorch. All you need to do is to choose the bad signs you want. That is kind of compatible with your heart. Where sex is good. I think so. Let's see how it goes through. Alright, we're done here. Not to think about normal that works, and specifically using its segmentation or on that works for image segmentation. Specifically for these kind of binary tasks like fault prediction. Like predicting foreground from the background. It is that we're going to end up with a 3D image. That's got values between 0s and 1s. So it's a probabilistic image, and since it is continuous, we need to actually threshold this, okay? To get the binary mask right. And I kind of used the ASCII threshold method to find out the best threshold. And it is giving us 30%, so 30% is the optimal threshold here, alright? So now we got our Joe bodies, and we can simply see what it looks like. Alright, now we've got it, as you guys can see. No fault plane, exactly the direction that we talked about. And it's cutting the image in the exact right places. So this is what I'm actually talking about. When I talk about old plane segmentation, or actual automatic fault extraction. This is what I actually talk about. Alright. So this kind of goes to show that how these commercial applications are actually struggling to keep up with the state of the art. Alright. So that's it for today, guys. If you liked the video, please make sure to hit that like button. Subscribe and turn on notifications because got more of these coming. And as always, thanks for watching. Catch you in the next one.